Welcome to the Virulent Vortex, a podcast in which we discuss infectious diseases across scales, from pathogens and molecules to populations and pandemics and everything in between. My name is Jaap de Rode. I'm a professor of biology here at Emory University. And today joining me is Ellen Bradley, who is a graduate student in the Population Biology, Ecology and Evolution program. Ellen, welcome to the show.
Thanks, Jaap. How are you?
I'm good, thank you. Let's talk about snails and fertilization and how that affects infectious disease.
Yeah. So I fertilize snails for part of my dissertation and the parasites that live in them. And basically similar to how you want your garden to grow if you give it fertilizer, right? Mm-hmm. Or it will grow if you give it fertilizer. The plants can get bigger. They can make better flowers to reproduce. Mm-hmm. That's kind of what the snails do too. But the snails also do another thing that the plants in your garden probably don't do, which is make parasites that infect people.
Okay.
And I'm trying to understand how the nutrients that I give them affect how many parasites the snails make. Okay. So that we understand how that changes human infection.
All right. So now let's break this down a little bit. So there are lots of different snails. You're speaking about a particular type of snail. So tell us about the snail and what parasites we are dealing with.
Ooh, yeah. So these are very little aquatic snails. So they live in freshwater ponds. If you have ever been to a pond or you have aquariums, you will see these kind of pest snails. Mm-hmm. They can reproduce themselves, so they're very difficult to get rid of because they don't require another snail to reproduce.
All right.
Yeah. So once you have a single snail in a water body, it's almost impossible to get rid of them. Yeah. So not only are these little aquatic snails there, they also have a parasite that causes a neglected tropical disease, schistosomiasis, which is what I study. Yeah. But even if you look at other kinds of parasites, this strategy of parasites living in freshwater snails is actually pretty common. And in the US, we have diseases that are similar where they can infect amphibians instead of humans.
Oh, really? Yeah.
Yeah, that causes their limbs to be malformed, which contributes to the amphibian decline. The snail just kind of releases each parasite into the water, and then they find their way to a human or an amphibian. And then they burrow into your skin. Okay. And then from there infect you. So humans transmit the parasite back to the snails. So there's always two hosts. So you can have a snail that can only infect humans, and then humans produce a different life stage of the snail. And through a couple of different means, it depends on what kind of parasite you're looking at, but that human can infect snails. Yeah. So snails can never get themselves sick. Right. And humans can't ever transmit these diseases to each other. You have to have both in order. Yeah.
Okay, and how do humans release these parasites into the water where the snails live?
So it's usually through some kind of sewage waste.
So you mentioned the schistosomes, the parasites in the snails, and you mentioned fertilizing snails. You made a very nice analogy that I want to fertilize my garden to get, bigger plants, more flowers. But why do you want to fertilize snails? Do we not want to get rid of them? And you're actually making them bigger.
Yeah, I'm making schisto worse for what I study. So there's two good parts of that. What I do is, the reason why I'm studying the fertilization is because in their natural habitat, they're exposed to high levels of nutrients. So like we talked about with sewage runoff, sewage is, even though it's disgusting, right? Because it has a lot of, just gross things in it. It also contains a lot of nutrients like cow poop does. And so things like nitrogen and phosphorus, the things you would think of giving to your garden, can come into the water bodies and feed the algae and plants and other food that snails eat. So then not only are they able to eat more food, but the food that they eat is also of a higher quality.
So you're fertilizing the food for the snails. So there's more food, the snails get bigger. And why is that important? So they produce more parasites, no?
Huge snail obviously has way more tissue. So it can harbor more parasite tissue and then release more parasites into the water. But a big snail also has to eat a lot of food. So if there is a lot of big snails in a water body, it might be that they are competing with each other so strongly for food that they aren't able to make very many parasites. Okay. But if suddenly they have this huge burst of food from heavy rain or from contamination from like cows or other livestock coming in and literally pooping in there, then that makes it possible for them to no longer compete with each other for food.
Okay, so you're experimentally fertilizing snails. You're fertilizing the food for the snails, but it is to understand what happens in natural situations where you get this big input of nutrients into water bodies, whether that's a river, whether that is a pond, and then to understand what the effect of that will be on the number of parasites and therefore the infection risk for people.
You asked a very good question of like, well, it sounds like you're making more snails and worse parasites, but like, why aren't you just getting rid of them? And I mentioned this in the beginning, but it's really, really difficult to get rid of the snails. So they are able to reproduce with just themselves, and they can do so really quickly. They're very hardy. So they're not always going to be there. Like, there are ways to eradicate them, but it's actually very difficult to do that effectively. And like I said, if you make it so there's less snails, even though you would think that, well, now there's a fewer number of infected snails, so all of the infection in the water body, like the parasites, should be able to go down. But if they're no longer like competing with each other for food, then now all you've done is potentially make it even worse than if you had done nothing.
You could actually end up with more parasites than fewer.
In theory, neglected tropical diseases are something that you should be able to fix pretty easily from a naive standpoint. So I get a question a lot, and people who study schisto get the question a lot of, well, if you just clean the water of the parasites or the snails, won't this make this problem go away? And in theory, that's true, but not only is that difficult from a snail perspective and a human perspective, but it takes a lot of different types of expertise to even know what management we should do. So you need doctors in order to give drugs to people whenever they're needed in these community settings of humans. You need public health people to tell you where are outbreaks and if they're correlated to certain water bodies or if they're correlated to like the school year. And then sense competition and what snails eat, what they, who eat them, they're predators. There's a lot of ecology that really matters. So having a team with disease ecologists in there is critical.
Yeah, and so with respect to your specific research project, what do you think is the most interesting or surprising finding, and how does it change the way we think about control of this disease?
I was surprised to find that nitrogen is a nutrient matters the most. So in a lot of different organisms, phosphorus, which is another component in things like fertilizer, is actually frequently the most important, especially for small organisms. And nitrogen helps you do things like build muscles, right, and process waste. And I was surprised to find that nitrogen played such a huge role because nitrogen also has a huge feedback from snails themselves back into the environment. So not only does the environment, so higher nitrogen from the nutrient pollution, impact the parasites and the snails, but the parasites also change how much nitrogen they poop out basically into the water body. So you can quickly see that there's this positive feedback loop of building nitrogen in the water body that can make things worse just over and over again. And I really wasn't expecting the effect of parasites on the environment with regard to nitrogen.
So you get these interesting feedback loops that are very unpredictable until you do the studies that you do.
Yeah, exactly.
Well, Em, it was really wonderful having you on the show today and learning about your work, really linking nutrients, algae, snails, and disease. Very interesting to find that ecological concepts can teach us interesting things about disease.
Yeah, thank you so much for having me.
We hope you enjoyed this episode. We look forward to seeing you again. Thank you for watching.